So on this question, it says find the standard form of the equation of a circle with endpoints of a diameter at points 9, 8 and negative 7, 6. So we're given that these are endpoints of a diameter. Maybe if we draw a picture, we can get an idea. So we have 9, 8. We have one point here and another point at negative 7, 6. Should be about here. And these are the endpoints of the diameter. And the diameter of a circle is going to pass through the center of the circle. So if we can imagine connecting these 2 points, we find the middle of that will be the center. And I'm just guessing where I've drawn that at this point. I don't know where exactly it is. And then the 2 points that are on the diameter will also be on the circle. So we're going to be able to sketch the circle. It'll look something like this. So we want to write the standard form of the circle, and the standard form is x minus h squared plus y minus k squared equals r squared. And that is where hk is the center of the circle and r is the radius. The radius goes from the center to a point on the circle. So in order for us to write the standard form, we need to find the center and also the radius. And what we're given is these endpoints of the diameter. So we have a couple of formulas that are going to help us to find the pieces of information we need. We need hk, the center, and r, the radius. So because the diameter is on the circle, we know that this center is right in the middle of those diameter, of those 2 points. So we're going to be able to use the midpoint formula to find that center. So the midpoint formula, you've given 2 points, x1, y1, and x1, x2, y2. And you would find the midpoint by averaging the x's. So that's adding the x's up and divided by 2. And then you're going to average the y's. So you add the y's together and divide by 2. So this is going to give us the midpoint. And in this example, because we have endpoints of the diameter, doing this calculation will give us the center of the circle. So we'll let our ordered pair 9, 8 be our first ordered pair, x1, y1, and negative 7, 6 be our second one, x2, y2. We're going to substitute it into that midpoint formula. We'll get 9 plus negative 7 over 2, and 8 plus 6 over 2 using the midpoint formula. So 9 plus negative 7 is 2. And then 2 over 2 is 1. So the x-coordinate of our center is 1. And 8 plus 6 is 14 over 2. And 14 over 2 is 7. So the ordered pair 1, 7 is the center of our circle. So we have the center, and then we need to find the radius. Now the radius is the distance between the center and any point on the circle. And those diameter endpoints are on the circle. So we can use either one of them to find the radius. And we're going to use the distance formula to do that. So with the distance formula, once again, we're going to start with two ordered pairs, and we're going to calculate the distance. That distance is the square root of x2 minus x1 squared plus y2 minus y1 squared. And that calculation is going to give us the distance between our center and one of the diameter endpoints, and this calculation will give us the radius. So it's going to give us the radius. So I'll use the center, and let's use this endpoint. So we're going to use the center as x1, y1, and then let's use this point as x2, y2. So we're going to have the square root of x2, which is 9, minus x1, which is 1, squared, plus y2. y2 is 8, minus y1, which is 7 squared. Okay, so then we'll continue to simplify. 9 minus 1 is 8. 8 minus 7 is 1. 8 squared is 64, and 1 squared is 1. So we have the square root of 65. I don't think that that can be simplified anymore, but let's just double check. I want to think about factors of 65. So we've got 1 and 65. Because it ends in a 5, I know that 5 goes into there evenly. So let's see, 65 divided by 5 is 13, and that confirms it for me. These are both prime numbers so that there are no other factors. And these factors are not perfect squares, so I can't simplify that. So now I have my radius. My radius is square root of 65. So now that I have my center and radius, I'm going to use the standard form, which is x minus h squared plus y minus k squared equals r squared. We'll substitute in the h and k. So the center is h and k. And we have square root of 65 being our r. Substitute those values in, and we have x minus 1 squared plus y minus 7 squared equals square root of 65 squared. And I'll simplify just this part on the end. The square root and the square cancel each other out, leaving me with 65. So I have the standard form of a circle with, let me scroll out a little bit here, the standard form of a circle with diameter endpoints of 9, 8, and negative 7, 6, being x minus 1 squared plus y minus 7 squared equals 65. For this question, we want to classify the given function as a polynomial function, rational function, or root function, and then find the domain. And we want to write the domain in interval notation. The function that we want to find, classify, and find the domain for is f of t equals the 9th root of negative 5t plus 6. So we want to classify this function as either a polynomial function, a rational function, or a root function. So I think this one might be a little bit obvious, but since the function has a ninth root, we would classify it as a root function. So anytime you have a variable that's underneath a radical, we would classify that as a root function. So we're going to classify this as root. And then we're asked to find the domain of this function. Now, when we find the domain of a root function, we have to consider the index, because we find the domain of an even indexed root differently than we find the domain of an odd indexed root. So we want to pay attention to whether we have an even index or an odd index. Now the index is this little number here, which tells us what type of root we're doing. Now the root is opposite of an exponent. So a square has a root of a square root. A cube, or the third power, has the opposite of cube root. So these roots, you have different roots because you have the opposite of different powers. So on that index, we notice that our index is a 9. And 9 is an odd number, so we have an odd index. So let's follow the details for this. So for odd index, there are no restrictions on the domain of that root function with an odd index. So for that reason, the domain of all root functions with odd index will be all real numbers. So what this is saying is that there are no restrictions and there's no calculation needed for finding this domain. So the domain will be all real numbers or negative infinity to infinity because it has this odd index. The reason why even index functions, even index root functions have restrictions is because the square root of a negative will give you an imaginary number. That's not a real number. So this happens with square root, but it also happens with all even index. So if you take the nth root of -1 and n is even, you get an imaginary number. However, if you take the cube root of -1, that's -1. So when you have an even index of a negative number, the even root of a negative number, you get imaginary numbers. But if you have an odd root of a negative number, you get a real number. So the odd index has no restrictions and will have a domain of all real numbers. Thank you for checking out my videos. Have a great day.